Have you ever felt a sudden warm breeze on a chilly day? That unexpected shift in the air can be surprising, even a little mysterious. It's as if nature flips a switch, and the world around you changes in an instant. Something similar, but on a much grander scale, is happening high above the South Pole, in the stratosphere, a region of the atmosphere that sits far above the clouds and icy surface below. Up there, temperatures are spiking by tens of degrees Celsius in just a matter of days. This dramatic event is known as sudden stratospheric warming, or SSW, and it's one of the most extreme temperature swings our planet experiences. Imagine the air over Antarctica, which is usually colder than a deep freezer, suddenly warming up dramatically, almost as if someone turned on a giant invisible heater in the sky. This isn't caused by the sun shining brighter, but by powerful atmospheric waves, called planetary waves, rising up from the lower atmosphere and crashing into the stratosphere above. When these waves break, they unleash a burst of energy, rapidly heating the air and setting off a chain reaction of changes in the atmosphere. This sudden heating disrupts the usual frigid conditions, jolting the powerful winds that circle the pole, and sometimes even reversing their direction. The result? A massive shakeup in the polar stratosphere that can ripple down through the atmosphere, sometimes even affecting weather patterns thousands of kilometers away on the ground. Normally, the polar stratosphere is isolated and stable like a fortress of cold air. But SSW events break that isolation, allowing new patterns to emerge. These events are rare in the southern hemisphere, making them especially fascinating to scientists who study the secrets of our atmosphere. Each SSW gives us a unique chance to observe how the different layers of the atmosphere interact, revealing hidden connections between the stratosphere and the weather we experience below. It's like a detective story unfolding in the sky, with every clue helping us better predict and understand future weather events and climate shifts. Science in action, right above our heads, reminding us how dynamic and interconnected our planet truly is. What gets disrupted by all that warming? As our planet heats up, the effects ripple far beyond just melting ice. The atmosphere itself begins to shift and change, setting the stage for dramatic transformations in our weather systems. The polar vortex, a huge, spinning mass of cold air over the poles during winter, sits at the heart of this story. It's a powerful force, shaping the climate of the entire northern hemisphere. Picture it as a giant, invisible spinning top, powered by Earth's rotation and the sharp temperature difference between the icy pole and the much warmer equator. This contrast is what keeps the vortex spinning, season after season. The vortex acts like a fence, locking in the coldest air and keeping it swirling above the Arctic, away from the rest of the world, at least, most of the time. It has two parts: a strong, well-defined core in the stratosphere, high above the surface, spinning with remarkable stability, and a more chaotic, shifting section in the troposphere where we live, where weather is constantly changing and responding to the forces above. These two gears are connected. What happens up high can influence what happens below, creating a delicate balance in our atmosphere. When the stratospheric vortex is strong, it keeps the jet stream flowing smoothly and the weather stable in the mid-latitudes, protecting millions from wild winter swings. But a sudden stratospheric warming event is like giving that spinning top a shove, an abrupt jolt that can throw the whole system off balance. The vortex weakens, slows, and can even split apart, sending ripples of chaos through the atmosphere. This disruption travels downward, eventually affecting the jet stream and surface weather sometimes weeks after the initial event. The result? Weather patterns become less predictable and more extreme. Think sudden cold snaps, unseasonable warmth, or powerful storms. It's a chain reaction that starts high above and ends up shaping our daily weather, sometimes in ways we never expect. The polar vortex is a key player in our planet's winter drama, orchestrating the movement of air masses and the fate of winter storms. When it wobbles, we all feel it, reminding us just how connected we are to the invisible forces swirling high above our heads. A wobbly vortex might sound distant, but its effects are real. When the polar vortex weakens, cold air escapes its grip, spilling out toward the mid-latitudes, like water sloshing from a bucket. The jet stream becomes wavier, making weather less predictable. In the southern hemisphere, this can mean dramatic changes for Australia, New Zealand, South America, and southern Africa. Weather systems can get stuck, leading to prolonged rain, heat waves, or cold snaps. The westerly winds that usually circle Antarctica weaken and shift north, opening the door for polar air to surge into new regions. Boundaries between climate zones blur, causing surprising weather. Farmers might face unexpected frosts, while parts of Antarctica see unusual warmth. These shifts impact agriculture, water supplies, and energy demand. It's a powerful reminder: a change high above can have far-reaching effects below. Everything in our atmosphere is connected. Let's zoom in on Australia, a continent where the weather can change in the blink of an eye thanks to powerful forces high above. When a wobbly polar vortex stirs up the atmosphere, it can flip the weather script entirely. Westerly winds, which usually stay further south, sometimes shift northward, dragging moisture-rich air over regions that are often parched, especially in eastern Australia. This sudden influx of moisture can trigger intense rainfall and even flooding in places like New South Wales and southern Queensland, transforming dry riverbeds into raging torrents almost overnight. At the same time, blasts of cold air from the Southern Ocean can sweep across the land, bringing unseasonable frosts to areas that are just beginning to warm up. These frosts can threaten crops right as they blossom, putting farmers on edge and risking the season's harvest. Meanwhile, in other parts of the country, blocked weather systems can trap heat, creating pockets of stifling air that refuse to budge. This leads to relentless heat waves in places like Western Australia, where the land bakes under a scorching sun and water becomes scarce. These dramatic shifts aren't just brief interruptions, they can last for weeks or even months, reshaping entire seasons and leaving lasting marks on the landscape. The impacts ripple through every part of life. Water storage dwindles, bushfire risks rise or fall, and agriculture faces new challenges with every change. Sometimes, increased rain brings relief and reduces fire danger in the east, turning brown fields green again. But elsewhere, prolonged heat and dryness can push the land to its limits, raising the risk of devastating bushfires and drought. It's a complex, ever-shifting picture, one with clear winners and losers, depending on where you stand. That's why meteorologists keep a close eye on the stratosphere, tracking every twist and turn. Because what happens 30 kilometers above Antarctica can redefine life for millions of Australians, shaping everything from daily routines to the nation's economy. The drama unfolding in the stratosphere is mirrored on the ground, where weather is anything but predictable. In Australia, the weather truly is on a roller coaster, one that everyone rides, whether they're ready or not. The polar vortex always weakens in spring as sunlight returns, but this year's event is no ordinary thaw. Normally the breakdown is slow and predictable, like ice melting on a pond. But a sudden stratospheric warming is a rapid, violent disruption, more like smashing that ice with a hammer. This year's SSW happened much earlier and faster than the usual spring transition. Such major midwinter SSWs are extremely rare in the southern hemisphere. Only one other has been recorded, in 2002. The southern vortex is usually stronger and more stable, thanks to fewer land masses and mountains to generate disruptive waves. That's why this event is such a big deal for scientists. With modern satellites and models, they're watching every detail, hoping to learn why it's happening now. It's a rare natural experiment, offering insights into our changing climate. Each SSW helps improve our weather and climate models. This isn't just another spring, it's a scientific milestone. The atmosphere is full of surprises. You might wonder, if this is happening in the southern hemisphere, why should the rest of the world care? Our atmosphere is a single interconnected system. A jolt in one hemisphere can send ripples around the globe. Think of it as a game of dominoes. Tip 1 in Antarctica, and another might fall in Europe or North America. Changes in the south can alter tropical circulation, which then influences the north. For example, shifts over the Pacific can affect El Niño, with global consequences. These long-distance links called teleconnections are a hot topic in climate science. The effects on the northern hemisphere are usually subtle and delayed, but they can influence the polar vortex and winter weather months later. This year's SSW is a perfect case study for scientists. It's a reminder, what happens above Antarctica doesn't stay there. Studying these events helps us understand the physics behind weather everywhere. Our climate is a global system, one big, amazing, interconnected puzzle. Every piece matters. Predicting the impacts of a sudden stratospheric warming is a meteorological puzzle. First, forecasters must spot the SSW itself, a challenge since it depends on unpredictable atmospheric waves. Once the warming hits, the next question is, Will the disruption travel down to affect surface weather? Sometimes it fizzles out, sometimes it triggers dramatic changes. Forecasters use complex computer models, running many scenarios to estimate probabilities. Even then, predicting the exact impacts, floods, heat waves, frosts, remains tricky. That's why you'll hear about increased chances, not certainties. Each SSW tests and improves our models. This year's event is a goldmine of data, helping build better long-range forecasts. Science is getting better at solving the puzzle, one event at a time. Is climate change making sudden stratospheric warmings more likely? The answer isn't clear, yet. Scientists are investigating whether global warming or ozone recovery is altering the frequency or intensity of SSWs. In the north, melting sea ice and changing snow cover might make SSWs more common. In the south, the healing ozone hole could be making the vortex more vulnerable to disruption. It's a complex mix of factors, and untangling them is a major scientific goal. What's certain, the world is warming and extreme events are becoming more intense. SSWs now play out in a hotter, more energetic atmosphere, amplifying their impacts. Understanding these events is more crucial than ever. So there you have it. A sudden stratospheric heat wave above Antarctica can send our weather on a wild ride. It all starts with invisible waves, disrupts the polar vortex, and ripples down to affect millions. This year's rare event is a scientific goldmine, helping us improve forecasts and understand our planet. What happens high above really does matter to us all. The atmosphere is full of wonders, and every new event is a chance to learn. So next time you hear polar vortex, you'll know it's more than just a buzzword. Stay curious, keep watching the skies, and remember, science is cool. There's always something new to discover.